ellipses, we've worked with their equations. Now we're going to look at the graphs. And how we can write an equation from a graph. So I started off easy by looking at this ellipse. The first thing you always want to do is you want to find your center. Okay, so when I'm looking at this one, you know you're looking at these endpoints. Like I said, I kind of made this one easy to start off with. So we can see here that our center, so what you want to do is you want to find the direct middle of your horizontal and your vertical axis. So our center on this one is at 0, 0. Okay, so you need to figure out, okay, my major axis, which one is the longer? Looking at this, my longer one is the vertical. So I know that I have a vertical major. The length of major, so the total length is 6, but remember, so because the total length of the major is 6, we know then that A is 3. The length of the minor, is 4. Therefore, we know that B equals 2. So I can go ahead and start and write my equation, and then from there figure out where my foci would be located. So my equation, remember, is in the form of x minus h squared plus y minus k squared equals 1, and we know that because it's vertical, the a squared is underneath the y. So this is our general form, so we can go ahead and plug in our information that we know. Since the center is at 0, 0, I'm just going to leave it as x squared. My b value is 2, so I know that's 4, plus y squared over 9 equals 1. So that right there is my equation, which is good. That's some of the information you would need to know. If you're looking for the foci, we have the A and the B value, but we don't have the C value. So you would need to find your C value, which, you know, we've got that A squared minus C squared equals B squared. Well, A squared was 9. B squared was 4. So we know that C squared is 5. So C is square root 5. So our foci then is located at 0, comma, 0 plus or minus the square root of 5. So that would be other information that you could find off of that. Now, like I said, I started off pretty easy because I started with a center of 0, 0. So moving on here. So let's go with this one. It's not quite at 0, 0. I can see where my endpoints are going to be located. I know the horizontal one for sure. So if you know where the horizontal one is for sure, but you're not quite set on the vertical, or I know the vertical one, I don't know the horizontal one. If you're not quite sure, remember it splits the difference. So we've got a total distance here of 3 to 5, so that's 8, so we're going up 4. So this is where the splitting of the difference is going to occur. So I can find my center, which is no big deal. So I've got my center here at 2, negative 1. Looking at this one also happens to be a vertical major axis. The length of my major, which I already counted, was 8. Therefore, A is 4. The length of the minor, length of my minor is 4. Therefore, B is 2. So now, like I said before, we can go ahead and write our equation. So we've got x minus 2 squared over, because it's vertical, we know it's the b squared, so we've got 4 plus y plus 1 squared over 16 equals 1. So that's my equation. And now I need to find my foci points. So the foci, remember, is located at h comma k plus or minus c. I got to find my c value yet by using my formula. My a squared was 16 minus c squared equals 4. C squared is then going to equal 12. So square root of 12 happens to be 2 square root 3. Going back to simplifying those radicals, you just can't ever get away from them. Therefore, we know our foci is actually located at -2, comma, -2, comma, 2, comma, -1 plus or minus 2 square root 3. Because I can't simplify with a 2 square root 3, I'm just going to leave it that way. So it's really not that bad to write our equation. The other thing is you will have to graph it from your equation, which isn't that bad either. Sorry, I forgot to actually put in a graph here. So give me a second. Ooh, good thing I'm fast with that. So let's say I've got x minus 3 squared over 16 plus y minus, or plus 1 squared over 4 equals 1. Okay, so notice here I picked easy values underneath 16 and 4. They're perfect squares. It might get a little bit challenging if you have like 20, then you're going to have a square root of something, so it's a little bit harder. Personally, I will always try to give you perfect squares so it's easier to work with. So our center is located at 3, -1. So I'm going to go ahead and plot that point. So I've got 3, -1. I know that the ellipse will not actually be on that, which I'm okay with. I just need to know that it needs to be centered around that point. Your major, so your A value, we're going with 16, but it's really 16 over 2, so that's 8. So what that means is I need to go 8 above that point and 8 below that point. So I've got 1, -1, so I'm going up 7 technically. 1, 2, 3, 4, 5, 6, 7. So this is the top. Ooh, what did I do wrong though? I went with the y-axis. Major is on the x. So I need to go 8 to the right and 8 to the left. Ooh, cutting her close there. And then 8 to the left. 3. So this is my major. I should have done that in blue there. Now I need my minor. My minor I know is 4 divided by 2. So looking at this, I know that my center is located at 3, -1. I'm going to go ahead and plot that point. I know this isn't actually on the graph, but I want to make sure that my graph is actually centered around that. My major is on the x. So I need to take the square root of 16 to give me my A value, and that's going to equal 4, which for the major means I need to go 4 to the right and 4 to the left because it's on the x. So that's where my major is. Now my minor is the square root of 4, which is my b, so that's 2, and that's on the y. So now that I've got my endpoints for my major and my minor, I can now connect my ellipse. Ooh, that end part was not good. I don't know if that made it any better. Anyway, so that's how you graph it. So you can use your equation. Notice you don't need to know your foci, which is okay. Like I said, I will try to give you perfect squares so it's a little bit easier to work with on your major and your minor.